Welcome to the class. In this session, we're going to be working on compound interest and annual percent yield. Those are the calculations that we're going to be working on. Remember always to do your homework, try as many examples as you can, and we're going to spend some time also using calculators. We need to be able to run some numbers. We have to make sure that we know how to calculate factors to an exponent, raised to an exponent. So that's what we're going to do today. This is section 10.3, and that can be found on page 583. You have it in the background there. And so let's get started. Let's get started. Section 10.3. Compound interest effective yield or annual percentage yield, APY. This is the homework that you have been assigned for this section. I've been telling you, reminding you to do your homework. Make sure that you submit it so that I can grade it and give you feedback. Please take a picture of the homework or type it up and email it to me so that you can get the credit for it. And also to practice the problems as we go along. We'll go through some definitions. So, compound interest is an interest that is computed on the principal on any accumulated interest is called compound interest. So basically, previously we worked with simple interest, but in this case we're compounding it. So that means that the money grows a little faster than when you leave it in simple interest. We're going to have an example to show you that. So this is the definition, right? When the interest is computed on the principal and accumulated, right? Every period that ends accumulates a little bit more, it adds to the principal, and then it goes on to the next period, accumulates more interest, and so on. Now, when working with rates, they can be paid annually, semi-annually, quarterly, monthly, and daily. This is very important. Make sure that you understand this because this has to do with the periods that you are going to have. So I'll give you an example here. For example, if you have a year and you have two paying periods, so you have 1 and 2, basically that represents a semi-annual rate that is paid, right? If you have a quarterly, then that means that you have 4 periods, right? So you have basically, in that case, for quarterly, you're going to have 1, 2, 3, 4 paying periods. Now, if you have a year, right? A year basically is only 1 paying period. This is 1, so this is just 1 paying period. This will be 2. This here will be 4, right? And so forth. So monthly, in a year you have 12 months, so you have basically 12 paying periods. And if it's daily, typically we don't use 365, but we use 360 as the number of effective days when you do your paying periods. Make sure that you review this material and understand how that is calculated, because when you plug in the values into a formula, you will need to know exactly what paying period you need to plug into your formula. As an example, if you are given as a quarterly, right? So when you have your paying periods, it will be 4 paying periods, right? So maybe we should put like paying period here, so that we know that that's what it means. Right, so you have those days when the interest is going to be paid, and it's compounded, so it will be growing more than if you have it in simple interest. Now, manually, we can calculate compound interest. And we basically have to use the formula that we know from simple interest. We practiced this formula before, we know this formula, right? Interest is equal to the principal, the rate times the time, right? And for the simple interest, the time is given in years. Okay, so in this case, what we do is we have an example where we are doing it for let's say for 3 years, in this kind, in this example. And what we do here is we calculate the first year, right? The first year. That's the first year that you calculate the interest. Let me use a different color, right? And then what happens is that the principal that you originally deposit or you make a loan, we call it principal 1, right? That's the point where we start. Now, when it comes to the second year, the interest that you accumulate from this first year is added to the previous principal. So you have basically principal 2, right? Now you have your principal of year 1 plus the interest. So basically, this gives you an amount, right, of money here. Now, when you calculate the interest for the second years, now you are going to do the principal of this, which is this addition of the principal 1 times the interest of first years, and you get this right now, right? So you get the second, this will be the second year here, right? Now, if we continue to do this, right, for the third year, our principal is going to be basically the P2 that we started from, and then with the interest that we earned on the previous year, and that will give us our P3 right here. And then we calculate the principal again, and that's where we get this principal. And for the amount that is well, that is like at the end of the 3 years, for example, we'll have that the amount is equal to the previous amount plus the interest, and that will be how you will calculate. Like this will be for the third year, and so on, right? So you can continue to go on like this and keep doing this manually, right? We are going to have an example as to how to do this manually. However, we have another solution in which a formula is given to us, and we need to plug in the numbers, but we need to understand how is that compound interest is increasing, right? Because every year you add the interest that you earn to the previous amount, right? So this was the previous amount and it's added to it, then you submit it to the next year to calculate the interest for the second year, so that this P2 is greater than the P1, right? And then to calculate the amount for the second year, we put that principal for year 2 plus the interest that you get, and so forth. So for the third year, this will be our third year. Right? The interest for the third year, but the amount, this is the amount, the total amount. That is accumulated over the 3 years time span. Of course, this is the total amount, but you have to remember that when it comes to calculating the interest that was earned, right, over that period of time, basically you take the interest is equal to A, the amount, the total amount, minus the original principal, right? In our case, it will be P1 to be able to know what was the interest earned over the whole period. Because this one is basically the amount that was accumulated, the total amount. But if they ask you for the interest, then you have to complete this other step, right? This is like the total amount, right? That was accumulated over that period of time. Spend some time on this, practice it, just to get an idea how compound interest really works. It's basically, you will see it step by step, and I will show you one using numbers. Let us consider an example using manual calculation for the compound interest. The problem states, find the amount of compound interest when $1,000 is invested for 3 years at 9% compounded annually. So from here we obtain our information. The principal, the original principal is $1,000. The rate is 9%, and it's compounded annually, right? So that we know that it's compounded annually. Every year is compounded. And for the period is 3 years. Now, when we do the calculation manually, we have to, the year that we have to use for every calculation is just 1, because we are doing manually. We are calculating every year the interest that is earned, and that interest is added to the previous principal. So right now we start with 1,000. The rate, remember, you do 9% divided by 100 to give you the decimal point. This is in percentage. This is the way you turn it into a decimal point, times 1. And if you look at here, these two zeros cancel with that, so you get 10 times 9 is 90. So it's the first year it earns $90. Now, if this interest is added to the previous principal, so you have 1,000 now plus 90. And so the principal that you're going to start for the second year is basically 1090. If you add 1,000, right? So you get $1,090. Now you to calculate the interest for the second years, you add the values, and now you pick the new principal. So it's 1090. Again, you plug it back into your formula. Right, this is every time that you plug it into your formula, so it will be the new principal, the same rate, and the year you get now $98. On the second year, you earn a few more dollars there, and the total amount for that one will be the previous principal plus the new interest for the second year, which is that, and that amounts to $11.88 10 cents, right? So that would be the amount for the second year. Now, when we calculate for the third year, the amount for the third year, the interest for the third year, we have the principal for the third year. We multiply it times 9 over 100, right? And if you do this calculation, it will yield 106 with 93 cents, right? So this will be the interest on the third year. And then you add that to the previous principal, and that will be your total amount for the 3 years right here. So this is the way the money has been growing. Now, we might want to know what was the interest that it was earned, or the profit that you get out of this, right? Extra money that you obtain. And to do that, we have to do a calculation where we say that I is equal to the amount, the total amount minus the original principal, right? The original principal was the one that you deposited. So if you do this calculation, basically you take 1,295.03, right? And you subtract the $1,000 that you originally invested, right? And then this will give you basically the amount of the interest that you earn. It will be 295 with 3 cents. And so that's basically what you need to understand in terms of calculating interest. The key in this example again is that the money continues to grow, right? Because the interest that you earn in the first year is added, right, to the second year calculation for the interest. And then this amount becomes the new principal, right? And then when you calculate the interest for the second year, you use this principal here, and you continue to obtain a new interest value for the second year. Then you add that capital plus the 98 again. You add in your interest, and that interest is invested again, and that's how the interest keeps growing. And in the end, the total amount becomes to 1,095.3 cents, right? So that's what you need to understand. And also this part here is very crucial, that you know that when you want to find, the money that you invested, how did it grow and what was the difference? And basically that's the difference, right? It went up by $295.03. This is a very important example to see how compound interest different from simple interest. Now, when working with compound interest, we can use a formula. It's a formula that we need to become very familiar with it, okay? So you have the total amount here. The principal, we know the principal is the amount of money that we either borrow or we deposit. And it's of course in dollars for us. Then we have the rate, is the annual interest rate. This is interesting, right? So it's an annual interest rate. So that's the rate that you need to plug in here. But if it says 9%, don't just enter a 9 here. You have to make sure that you do the right calculation there. And the N is the number of compounded periods, paying periods per year, right? If it's quarterly, then this number will be 4. If it's semi-annually, then that number will be 2, and so forth. Make sure that you understand this formula really well. And for those who don't know how to work this calculation, make sure that you practice it with your calculator. I'll give you an example as to how to plug in the values to give you a tutorial on that. But this is really important to be able to solve these kind of problems, okay? That's the compound interest formula. Very important formula. We need to know it. Let's do one example here. So in the example of that we used earlier, we had $1,000, right? And we invested it in a compound interest, and we did it manually in the previous example. Now we're going to use the formula. So our amount is going to be equal to the principal, which is 1,000, right? This is 1 plus the rate. Now remember, the rate is 9%, so it's 9 over 100 divided by the periods, right? And in this case, is compounded annually. So basically, the calculation that we have in this regard is going to be 3, right? Because it's going to be compounded annually. I'm sorry, this is 1 here. This is 1. And this one up here is going to be, the paying periods will be 1, and the 1 up here will be 1 times the number of periods is 3. Right? Sorry about this one. This is 1 right here. So when we carry out this calculation, this will be 1,000, right? And here we know that this is basically divided by 1, so this is basically 1 plus 9 over 100, right, raised to the third power. So this is equal to 1,000. And this one here, if you remember, the decimal point is here, so we have to move it 1, 2. So it's 1 point, right? We have the 9 here. So it's 1, we move it 1, 2. So this will be a 0 right there, right? It will be 0.09 here. You add it to a 1, you ended up with that, and now we raise this to the third. Now here is when some of you most likely will have some difficulties, and so I'll show you how to do that. Right, in your calculators, make sure that you become very familiar with your calculators, right? In this particular case, in this calculator, you can see here there is like an arrow pointing up. Thus, basically, it means that the number is raised to a power. So in our case, we have a 1.09, and we need to raise this to the third power, and then we enter it, and we get 1 point. If you can see it clearly, there is 1.2950. Okay, that's the way to calculate this this number raised to the third power. And now from here, we know that this is equal to, if we multiply by 1,000, that means that we need to move the decimal point 1, 2, 3, right? So the answer here will be 1,295, right? And if you remember, when we did the manual calculation, we got a 3 cents here. Here we basically lost some of that. Now, if this is the total amount, but if you want to know the interest that was earned, right? So we have to plug it in here, following this formula. So it will be 1,295 minus 1,000, and it will give you 295, right? So that was basically the interest that were earned. If you remember, it was the same value that we obtained when we did it manually. You can see the comparison here. You see the numbers? Here, it's a lot of calculations, do it manually. With the formula, you have to be careful when you pick the entries that you have to do, right? Like when it says here compounded annually, that means that it's only one paying period, right? So make sure that this is a 1, right? This is a 1 right here. And then all you have to do after that is basically arithmetic. And I know that this part here could be confusing for some students. That's why you need to know your calculator, right? Every calculator is different, right? In this case, I show you here the arrow that you have to plug in, and I'll show you with another calculator. All the calculators used to do it differently, right? Like for example, we have 2, let's say raised to the, let's do it again. Let's say 1.09 raised to the 3 gives you that, right? And with this calculator, it's basically different. It says it will be 1.09 to the 3 is equal to that. As you can tell, the calculators, they look different, and the values, the results that they give you, you know, they are basically 1.95029, 1.95029, right? And if you look carefully on this calculator, it waited a little while to give us a response. This is an older calculator, and a number raised to a power is done like this in this case, y raised to the x. In our case, in this calculator TI 30XS is given you as an arrow. Okay, so this is basically symbols that people use. The arrow basically means raised to a power. If you take computer classes, most likely you will see that sign. Okay, so that's what the example that I would like to show you with this one here. And let's continue. Then we have another example, example number 2. Okay, for those who have the book, right, page 584. In page 584, you will find this example, and basically it is saying that Kathy invested $3,000 into a savings account at interest rate of 1.8%, right? Compounded monthly for 2 years. So the key in this problem is to find out, like for example, the principal is equal to $3,000, right? We have it here. Then we need to look at the interest rate. The interest rate, the rate is equal to 1.8%. It's compounded monthly, right? Compounded monthly, that means that the paying periods are going to be 12 months, right? Because there are 12 months in a year, so n is equal to 12. And this is going to be for 2 years. Our t is equal to 2 years, right? So that's what we need to make sure that we know to be able to plug it in into our formula. So for the total amount, this is going to be equals to what? 3,000. The rate is 1.8, right? We remember we have to divide by 100, right? And the n is divided by 12. And this has to be multiplied by n. N is equal to 12. And the t is equal to 2. So what is that? What is that equal to? Right? So let's simplify this a little bit. We have 3,000. 1 plus. Now this number here, remember you can move the decimal 2 locations. So we have a 0.018 divided by 12. And then we have to multiply this number. This is basically 24 right here. Now that's equal to what? We can use the calculator here, right? So we have 3,000. And this 0.18 divided by 12, this yields 0.0015 raised to the 24th power. Right. In this case, we have to calculate the exponent. This exponent first, right? The number that we'll get here, and this one, if you do it correctly, will give you a number of 1.0366279, right? And then when you multiply times 3,000, you get 3,109.88. This is, of course, has to be in dollars, right? You can do the problem and put the units at the end. You don't have to be writing the dollar sign all across here. But this part here is where you have to be careful, right? So let's practice this part here. Make sure that we know how to do that. We continue with the effective annual yield. This is a definition. The effective annual yield, or annual percentage yield, APY, is the simple interest rate that gives the same amount of interest as a compound rate over the same period of time. That's a definition that we need to know. Now, how do we calculate the annual percentage yield? And the way to do that, basically, we have the same formula for the compound interest. The key here is that the interest is calculated on a $1, right, for 1 year. So the principal is $1 and the time is 1 year. And remember, the interest is always giving us the amount minus $1, right? That's the $1 that we'll calculate it. So that's basically what you need to do. So let's try an example. You'll find this one on page 587. It says, determine the APY for $1 invested for 1 year at 2% compounded quarterly. Right? Quarterly means n is equal to 4. So in order to calculate this amount, we need to plug in the values here. The principal is $1, 1 plus the rate is 2%, right? So it's going to be 2 over 100. And the n, right, is quarterly. So our n is equal to 4, right? There are 4 payments when we do quarterly. And all this will be raised to the n multiplies times t, right? And then we remember that is equal to 1, so it will be 4 times 1. So now we need to calculate this number, so we'll get basically, we can write the 1 if you like, but basically we know that it's 1 times this, right? But just for the sake of it, just say 1 times 1 plus this one here, we know that it's going to move the decimal point two places, right? So we'll get 0.02 divided by 4, and this will be raised to the 4th power. So that's basically equal to what? That would be equal to 1 times, if you follow this calculation here, have your calculators always handy, you get 0.02 divided by 4, that gives you 0.05. This will be 1 plus 0.05 raised to the 4th power, and that's equal to 1 point, right? That's equal to, that would be equal to 1.021. And now that number, this number will be basically 1.005 raised to the 4th power, and that will be equals to what? Clear here, 1.005 raised to the 4th power. That gives you basically around, its approximation is 1.0201, right? So you can say, if you want to make it equals to like a closer to the cents, right? If you want to do it closer to cents, you can just leave it at 102, or you can just leave it like that. And then to be able to do the calculation that we have been asked at the end, we say that the interest, right, is going to be equals to A minus the $1 that we invested, and so that will be equals to what? So it will be 1.020 minus 1, right? It's the $1 that we invested. So basically this is going to be equal to 0.02, right? And that's, you can leave it at that. That would be your answer for the interest. The interest would be 0.02. And that would be your answer right there. So Make sure that you practice your calculations carefully with the calculator, but that's what you need to do to be able to solve this problem. Let's just spend some time on it, because it's good always to review what is that we're doing. It's not just about plugging numbers, right? They're giving you an APY calculation, right? Annual percentage yield. And we know that to do that, we need to use the compound interest formula, but we have to remember that it's based on $1, right? It's $1. That is the principle, right? That's our principle. And the other thing that we need to know is like the rate is given to us of 2%, right? We have to remember that 2%, when we use it in our formula, it has to be in decimal form, so this will have to be 2 divided by 100, right? And that's when we get the 0.02. And the other thing here is that it's compounded quarterly, right? If you remember when I told you that when you have paying periods, right, you have 4 paying periods, so you have 1, 2, 3, and then you have 4 paying periods, so you have 4. That's where your n comes, right? N is equal to 4, because the paying period is doing quarterly, right? Those are the key words that you need to understand. The other concept is that to do the calculations in terms of the interest for annual percent yield, you have to subtract 1. This is a 1. This is the dollar that originally was invested here, right? That has to do with that dollar right there. This is $1, right? Right. So that's basically what you need to do. And again, remember to do this carefully. When you're doing these steps, don't rush. Do it slowly, and double check with your calculator, right? And this is the part where you need to pay special attention how you enter it in your calculator, right? One way that I sometimes do to test things is, if I don't know a calculator, just to give you as an example here, let's say I have a 2 raised to the third power. I know that's equal to 8, right? So I can go like this and say 2 raised to the third power. I know the answer is 8, so I test it, and I get my number 8 right there, right? You can see it right there. So you have to, sometimes when we don't know calculator, we have to plug in the numbers and try them until we know exactly where we need to punch the key so that we get the right answer. So this is one example, page 587. And that was part A that we solved, part 8. Let's move to part B. It's a similar example. In this case, they're saying that we still have $1 for 3 years, but it's compounded monthly, right? So our n is equal to 12. So let's solve this one quickly here. So we know this is 1. Then we have 1 plus, we already know the calculation for this will be 3 over 100, right? And all this will be divided by the n, which is, in my case, now it will be 12, right? And all this is going to be raised to the n. Now my n is equal to 12, right? But it's for 1 year, so I multiply times just 1. The t here is 1, the n is 12. So this is equal to 1. Right, this one, I have to move the decimal 2 points, so it will be 1 plus 0.03 divided by 12. And all this will be raised to the 12th power. If I continue to do this calculation here, the answer for this is going to be about, because the calculation with truncation numbers will be like 1.0304, and so your interest, right, is going to be equal to A minus $1, and so the answer will be 0. It's going to be about 0.0 0.0304. So that's basically your answer for there. Make sure that you, again, read carefully, review the material in the class, because everything has been given to you to be able to solve these problems. And let's spend some time with the calculators again, one more time. You know, on using these calculators. And I'll have the old one again here. Right, so we have two calculators, and again, like I said, if you are going to do something like calculating numbers, make sure that you do something like, let's say, 2 to the fourth, for example, right? If you want to calculate something, just to test to know that you know what to enter into the calculator. So in this particular calculator, we need to punch in where it says it has like an arrow, right? In computer science, they use arrows. In this case, they will represent this number as 2 to the fourth power, right? For the arrow here. But in this calculator, they don't have an arrow. They have a y of x, right? So basically, they're saying that this number y, in our case is 2, is going to be raised to the fourth power. Okay, so that's basically what you need to do. So let's just as an example, let's say we have 2 raised to the fourth power, give us 16. So here we have 2 raised to the fourth power is equal to 16, right? So this is equal to 16, this is equal to 16, and this is equal to 16. Now, when you're doing your calculations, this is just as a tool as to how to use this number. There will be numbers sometimes that will be different, but you just make sure that you do it step by step, right? This is just to give you an example, right? Like how to do these calculations using your calculator. So we'll call it here using calculators, right? Now every calculator is different, and you have to know it yourself really well. Otherwise, you're going to be guessing, you know, and that's why you need to do this kind of tests to make sure that you know your tools. These are basically some tools that we can use, and they are at our disposal to do that. And before we finish for this section, there is another calculation that we need to know. And it has to do with present value. It comes back again from our calculation for compounded interest, right? So in the amount is equal to principal, right? 1 plus the rate divided by the number of paying periods, right? That's our formula. And then to find the present value, what you need to do is we need to solve for P. So what is P equal to? If we solve for P, that means that the A, let's say for example, A remains here, right? And then P is here, and we divide everything by this amount here. So we divide this, and we divide this by 1 plus Rn to the nt, 1 plus Rn to the nt, right? This is not multiplying here, that's just adding here. So this basically goes away, and so our P then basically it says that is equal to this over 1 plus R over N to the NT. So the present value, if you want to put it this way, is equal to A, right, divided by 1 plus R N over NT. t. Okay, so this is your formula for the present value. This is something that you already know. We already done some algebra, and this is basically some of the manipulation that we can do. So this is the present value formula. Thank you for your attention, and make sure that you email me if you have any questions. Do your homework. It's important to do your homework. That will help you to solve the problems and understand the material. Have a great day.